take a look at this problem. We got negative 4 over 9x to the third times 15x over 32. Okay, first I'll do it the simpler way, and then I'll go back and do it a little bit longer way. Simple way is nice if you can actually see what divides into what. Okay, now we're looking for a number on top and a number on the bottom. They don't have to be in the same fraction. They can be, but they don't have to be. And I'm going to choose, to begin with, this 9 and this 15. So a number on top and a number on the bottom. And we're looking for the largest number divides into both of those, which would be 3. So 9 divided by 3 is 3, and 15 divided by 3 is 5. So we'll have negative 4 over 3x to the third times 5x. And I'm going to go ahead and put a first power here. Anytime you just got an x, there's implied first power there. And 32. Okay. Still working with the numbers. I see I got 4 here and 32 here. I think the largest number divides in both those, which will be 4. So 4 divided by 4 is 1. 32 divided by 4 is 8. So I'm going to have negative 1 over 3x to the third times 5x to the first over 8. Now I could handle the x's at this point, or I could go ahead and just multiply them together then handle the x's. And I'll go ahead and multiply them together then handle the x's. So negative 1 times 5 is negative 5, x to the first. You multiply the numbers together separately, and then x to the power just carries along. 3 times 8 is 24, and we got x to the third. Okay. You shouldn't have to worry about the numbers anymore if you did a good job up here canceling your numbers. So let's handle the x's. Whenever you have x to a power over x to a power, you subtract a smaller exponent from a larger one. So 3 minus 1 is 2, and we're going to have x to the second power where our larger exponent was, which was on the bottom. And that's our answer. Okay, now let's do this again differently. Okay, so I got negative 4 over 9x to the third times 15x over 32. If you're not very good at seeing what divides into these, like the largest number divides into 4 and 32, what you can do is you can do the prime factorization of each one. Well, if I start with 4, start with my first prime, which is 2. 4 is divisible by 2. 2 times 2. So this first fraction, we get negative 2 times 2. Now down below we got 9. 9 is not divisible by 2, so I go to my next prime, which is 3, and it is divisible by 3. 3 times 3. Okay, 15. Not divisible by 2 by going to 3. It is divisible by 3. 3 times 5. And then 32. 32 is divisible by 2, my first prime. 2 times 16. 16 is divisible by 2. 2 times 8. 8 is divisible by 2. 2 times 4. And 4 is divisible by 2. 2 times 2. So it looks like I got 5 2's there. So 1, 2, 3, 4, 5. Okay, now we're ready to do some canceling. The only guideline is one's on top, one's on the bottom, and they're the same. Here's a 2, here's a 2. Here's a 2, here's a 2. Here's a 3, here's a 3. And that looks like it. So let me put it together here. What am I left with up on top? Of course, the negative, and then 5x. And down below, we have 3, and then 3 2's. And then x to the third. Okay, let me multiply those numbers together first. Negative 5x, and I'm going to go ahead and put a first power here, because again, whenever you have an x, that's the x of first power. Down below, 248 times 3 is 24, x to the third. Okay, the numbers we can't do anything else with. Just like the previous method, we got extra power over extra power. You subtract a smaller exponent from a larger one. 3 minus 1 is 2, and we have x to the 2 power, where our larger exponent was, which was in the bottom. And that's our answer.